last time we got a conceptual overview of what a derivative was, right? And we figured out by that secant tangent line argument that the derivative at a point f prime of a is f of a plus h. Oops. It's the limit as h approaches 0. Don't forget the limit of f of a plus h minus f of a all over h. And the picture that we were going for was the parabola f of x equals x squared. And so f prime of a gives the formula at one single point. But if we do the calculation for every single point, we will get the same formula. So instead of a, if we pick any point x, the same formula still holds. So limit as h approaches 0, and everything else remains the same. F of x plus h minus f of a all over h. Okay, so that's the formula, and now let's calculate the derivative of f of x equals x squared. So how do I do that? Okay, so let me just do this. Equals the limit as h approaches 0. Now what does this f of x plus h mean? That means wherever I see an x in this f of x, I'll replace an x plus h. So if I replace the x plus h on the left-hand side, wherever I see an x on the right-hand side, I will replace an x plus h. So that x squared actually now becomes the quantity x plus h squared. And oops, this is actually f of x minus f of x, which is just the original function x squared all over h. And that's the basic setup. So now actually let's just do some plain old algebra and compute this. So limit as h approaches 0, x plus h quantity squared, this is x squared plus 2xh plus h squared parentheses minus x squared all over h. Aha! What do we notice? We notice that the x squareds go away. And so we are left with the limit as h approaches 0 of 2xh plus h squared over h. Now, before we plug in the limit as h approaches 0, we could do some simplification. We see an h on the left-hand side of the sum, we can cancel that. And h squared divided by h is just 1 power of h. So finally, putting everything together, we have the limit as h approaches 0 of 2x plus h. Now, when we want to compute the limit as h approaches 0 here, well, you just plug and check. Wherever you see an h, you plug a 0. So that's 0. So our final answer is actually just 2x. So let's conclude. We started with f of x equals x squared, and we ended with f prime of x equals 2x. So the derivatives of f of x equals x squared, f prime of x, or also known as d dx of x squared, is equal to 2x. Now what does that mean? Let's compute some values. Let me draw that graph again of the parabola. Okay, and let's plug in some values. At x equals 0, 2 times 0 is just 0. So what we're saying is that the derivative at 0 is 0. which is just a horizontal line, right? Y equals 0. Okay, so that's one value. Now, how about we calculate f prime at 1? That is 2 times 1, which is 2. So that's sort of the line y equals 2x. That's a slope of 2. Let's do another one. F prime of 2 is 2 times 2, and now things are going twice as fast. So it's increasing 4 times. That's at 1, that's at 2. And let's do the same thing on the negative side. F prime of negative 1 is 2 times negative 1, and now we see that the slope is negative 2. And similarly, we'll get slope is negative 4 for the point negative 2. And that's it. We have found the example of how to figure out the derivative using the definition of the derivative.